For the final section of this chapter, we're going to talk about naming covalent compounds. So we already talked about the ionic side, and now we're going to talk about covalent. Okay, so when you're naming covalent compounds, first thing is to recognize them. Now again, whenever we're working on these, I will separate them out so you know which naming system to use. But covalent compounds, basically they're going to be within these three columns. Now as you get lower and lower down in this block here, it's less and less likely that you're going to see them in the covalent compounds. You can also add hydrogen into this. Okay, so these are really the elements that like to do covalent compounds. Now with covalent compounds, they can combine in a lot of different ways. Okay, so you can have multiple compounds that have the same elements in them, but just different numbers of each element. Okay, so it's really important to be able to note the number of each element versus just what the elements are, or if it's a polyatomic ion like we were doing in 6.3. So covalent compounds will use prefixes to kind of get around the number issue here. Okay, so they will tell how many atoms of each element are in the molecule. So really what you need to know for this are these prefixes. And it's just 1 through 10. You're probably already familiar with quite a few of them. You have 1 is mono, 2 is di, 3 is tri, and you have tetra, penta, hexa, hepta, octa, nona, and deca. Okay? Those are the 10 you need to know for covalent compounds. So if there is only one atom of the first element listed, no prefix is used for it. If there's one of the second atom listed, of the second element listed, then you use the mono. Okay? So for an example, if you have water, it's H2O, okay, there's one oxygen, but oxygen is listed second. Okay, so you do have to use the prefix. So talking about water, if you were going to name it in this system, would be dihydrogen because you have 2 hydrogens, monoxide. Okay, because there's one oxygen. So dihydrogen monoxide tells you right there you have 2 hydrogens, 1 oxygen, H2O. There you go. So the second element still uses the IDE ending. Okay, the main key to being able to tell if you're looking at a name, to be able to tell if it's ionic or covalent, are the prefixes. Okay, if there is a prefix in the name, it is covalent. All right, here we go. So we have 1 carbon, 1 oxygen. All right. Now, because the carbon is listed first, we don't need to worry about our mono part here. Okay, so we just write carbon. Because there is no prefix, we go ahead and assume from this name that there's only 1. Okay, but then we have 1 oxygen, and we need to note this time that there is only 1. Okay, so mono. And then we change the ending of the oxygen to IDE. So it's monoxide. So this is carbon monoxide. Okay. You may have heard of carbon monoxide. It is actually an odorless, colorless, poisonous gas. Okay. It's let off through burning things. So that's why chimney sweeps were such a big deal. Back when people used burning wood and coal and things like that in their houses to keep warm, because the chimneys and the vents would actually let the carbon monoxide out of the house instead of accumulating inside the house. So carbon monoxide, yeah, not very good. All right, now we have a very similar compound. We just have added in another oxygen. Okay. So we still just have 1 carbon, but it's the first one listed, so we don't have to put the mono. Okay, so it's just carbon, all right? And then we have 2 oxygens, so dioxide, carbon dioxide. pretty sure you've heard of that one as well. Okay, it's what you breathe out. All right, so now we have a single silicon, and we have 4 chlorines. So it's silicon, silicon, silicon. Okay, again, it's the first element listed, so you don't have to put mono in front of it. Now we have 4 chlorines, and remember what the prefix for 4 is? It's tetra. So tetra, and then chlorine, you change the ending, it becomes IDE, so it's tetrachloride. Okay? Silicon tetrachloride. All right. Next up, now we have 4 phosphoruses and 10 oxygens. So this one becomes tetraphosphorus. Now remember, the phosphorus is listed first, so we don't have to change the ending to IDE. Okay, so it's tetraphosphorus, and then if you remember, okay, deca is for 10. Now this is where it's a little bit of wiggle room. You could do decaoxide or decoxide. Okay, I like to cut out the A whenever possible. Okay, but you can only do that if it starts with another vowel. Okay, so decaoxide or decoxide, either one is technically correct. Okay, tetraphosphorus decoxide. Yes, it takes a while to get used to saying these as well. All right, 2 silicons, 6 bromines. So the prefix for 2 is di, so disilicon. And what was the prefix for 6? It's hexa. Hexabromide. Disilicon hexabromide. And next up, again we have 2 phosphoruses, so it's diphosphorus. Here we go. And now we have 7 oxygens. Okay, so this time it's hepta. But again, because it's an A and an O, okay, you can cut out the A and heptoxide. Or heptaoxide, either way works. Okay, now one thing to note here is that we have diphosphorus heptoxide and then tetraphosphorus decoxide. Okay, they are both constructed using the exact same elements, but they have different numbers of each element. Okay, so that's why the prefixes are really important, because if you just said, you know, it's phosphorus oxide, okay, cool, how many phosphoruses, how many oxygens? Because P4O10 is incredibly different from P2O7, right? All right, so now let's do it backwards. Nonacarbon pentahydride. Okay, nona, remember, is 9, and then we've got carbon, right? So 9 carbon. Penta, remember, means 5. Hydride, okay, cut off the IDE ending, and this one is hydrogen. Okay, so we have 9 carbons and then 5 hydrogens. So C9H5. Next up, sulfur hexafluoride. All right, so notice there is no prefix instead of sulfur in front of sulfur, so that means that there is only one of them, because again, you do not use mono if it's listed first. Okay, so you can use mono in the middle of the name, like here it would be, but you can't use it to start off a name. So you've got 1 sulfur, and then hexa, remember, means 6. Fluoride, cut off the IDE ending, and it's fluorine. Okay, so it's SF6. Dinitrogen tetraoxide. All right, so this means we've got 2 nitrogens. Tetra, or tetraoxide, means that we have 4. Okay, so dinitrogen in 2O4. All right, phosphorus pentachloride. So again, we do not have a prefix, so this means you just have 1 phosphorus, and then penta means 5. So PCl5. Next up, sulfur trioxide. Again, no mono or prefix in front of sulfur, so it's just 1. And then tri means 3. Now, notice there is an IO here, so again, when it's the double vowel, it's kind of iffy as to whether you put both of them in there or not. If it's an A, generally it'll get cut off. If it's an I, generally it stays. Don't ask me why. Again, this goes into a lot of why is English the way it is. There's that saying that English is constructed by mugging other languages and going through their pockets for spare grammar. Take from that what you will. I am not an English teacher. Okay, so here we have 1 sulfur, and then the trioxide, we have 3 oxygens. So SO3. Now what you notice, okay, because SO3 might seem familiar to you, especially if you've been memorizing your polyatomic ions like you should be, okay? But what you'll notice, there is no charge here, okay? So this is not a polyatomic ion. If it were sulfite, it would be this, with the 2 negative charge, okay? It is not. We do not have that charge, so it is a covalent compound here, okay? Not a polyatomic ion. Next up, dinitrogen monoxide. Okay, so you'll see now we finally get to use our mono, okay? Obviously, we're not using a double O in this, so it's not monooxide, it's monoxide, okay? But like I said, you can't have mono to start the name, but it can be in the middle of the name, like you find it here, okay? Now again, di means 2, mono means 1, so we have dinitrogen, okay? So N2 monoxide, 1 oxygen, N2O. All right, and that is it. There you go.